Today we're going to look at section 1.7. One point seven's title is Modeling with Equations. And it starts on page 65 in your textbook. So we're going to give some general steps. You might make your own steps, but in this case we're going to look at 6 different steps. Steps for modeling an application problem. Sometimes you may have heard it called a story problem. So step number 1 is to read the entire problem. What happens a lot of times is people will read part of the problem and think they know what it's asking for, but then when they get to the end, they find out it's not what they're asking for after all. Number 2 is draw a picture or a chart. Now I'm going to write in parentheses, if necessary. So if you're talking about a rectangular garden, then I would think a picture of a rectangle would be helpful. If you're talking about a mixture problem where you're mixing several different things together, then a chart would be a good thing to try. But if you're talking about 50 babies, then obviously you wouldn't have to draw 50 babies. So number 3 is to label the variable. So the unknown is the variable. So you might say let x equal the number of dollars invested at 6% or something like that. Number 4 is write an equation or inequality. Number 5 is to solve the equation. / inequality. And number 6 is to check your answer and put your units. So we're going to say put units on answer. And check. Now, on putting units on your answer, that's like feet or inches or pounds or whatever the units has to do, because we don't know whether it's feet or whether it's inches make a lot of difference. The idea of checking might just be a mental check. If I invest $50 into a savings account, then how much interest am I going to get back in 6 months? I'm probably not going to get $1,000 back because I only invested 50. So I may have the decimal in the wrong place. So check your answer, even if it's just a mental check, to see if your answer makes sense. Okay, so the first one we're going to look at is on page 65, renting a car. I'm going to let you pause at this point to read, but I'm going to also read it to you as well. Renting a car. A car rental company charges $30 a day and 15 cents a mile for renting a car. Helen rents a car for 2 days and her bill comes to $108. How many miles did she drive? Okay, so we're looking at the unknown. We read the entire problem. We don't need to draw a picture or a chart because we don't need to draw a picture of her car or whatever. Label the variable, the unknown then. So we're going to say let m equal number of miles driven, because it wants to know how many miles that she drove. So what happens with this? It says that we have $30 a day, 15 cents a mile. So $30 a day, and it says that she has a car for a total of 2 days. So you're going to have $30 times 2 to start out with, even without driving any miles at all. So this would be our daily rate. plus, then after the daily rate that you have to pay just for taking the car, then you've got the cost of miles driven were 15 cents a mile. So if you have M miles, then this is going to be 0.15 M. Now, why did I not put just 15 M for 15 cents? Well, the reason why I didn't do that is because this 30 is $30. So this 15 has to also be dollars. Our units have to match across the problem. So be aware of that. So we ended up with a $108 bill. So now I've got the daily rate, the mileage rate. So this is the cost of the miles. And this is the total then, right? So now to solve, 2 times 30 would be 60 plus 0.15 M, 108. We're solving for M. To get M by itself, we're going to take the 60 over, minus 60 to both sides. 0.15 M equals 48. Divide by 0.15. So we end up with M is 320. Now, thinking back on your steps, you can't just leave it as 320 because that could be 320 inches, 320 feet, 320 miles. So what is the unit going to be? If we look up at our let M equal number of miles driven, then we know this is miles. So we're okay. Let's try another one. This next one is the dimension of a garden. So we're going to find that on page 67. So like I said, if you have the book open, you can look at that. So it says a square garden has a sidewalk 3 feet wide around its outer edge. If the area of the entire garden, including the walkway, is 18,000 feet squared, what are the dimensions of the planted area? Okay, so we're looking at the dimensions of the planted area, and then it has a walkway around the outside of it. But we also know that it's a square, so we have to know something about a square. What do we know about a square? All the sides are the same, so this would be the same as this, would be the same as this and this, and all the angles are 90 degrees. So it says that the walkway is 3 feet wide, so we've got 3 feet wide. And let's talk about our steps again. So we read the entire problem, so now we're drawing the picture. So the square dimensions we don't know. That's what we're trying to find out. What are the dimensions of the planted areas? So there would be labeling our variables. So let x equal this length from here to here then, right? That would be the planted area. But what else do we know about x? X is all of these all the way around then, right? So x equals the length of one side of the square garden. Now, what else do we know about the length of that side? Is it feet? Is it miles? Is it yards? Is it meters? So we look back at our problem again. It says that the walkway in the garden, it says 3 feet wide around the outside. So we're talking the units to be feet. So we're going to put that in parentheses to remind us. So now what happens to the area, because it tells us the area of the area is 18,000 feet squared. The area of the entire garden, including the walkway, is 18,000 feet squared. So how do I get this outer dimension? If I know this is x and I know this walkway is 3, this is x and this is 3, but it's also 3 over here too, and it's 3 over here. So what does that make the dimensions of the whole side be? Well, you're going to have x plus 3 plus 3. So this distance between here and here is going to be x plus 6 because you got a 3 on either side. So we know that our Length side is x plus 6, x plus 6, x plus 6, x plus 6, again because it's a square. But if this is area, area equals side squared when you're talking about a square. So we've got 18,000 equals, what's our side? X plus 6 squared. Now, if we think back to our previous example, the question's going to ask us for what are the dimensions of the planted area. So we have to solve for x. So we're going to take the square root on both sides. This gives me x plus 6. Remember we did the square root method. 18,000, the square root of 18,000 is going to be approximately 134.164. So this is going to be an approximately question. And then minus 6 from both sides. So the garden dimension this is going to come out to be 128 or 127 point something, so it's going to round to 128 feet. So my dimensions are 128 feet by 128 feet. And we're going to put approximately because we rounded. On this kind of problem, make sure you're careful to read the directions on what they want you to round to, because that'll make a difference too in your answer. Give everybody a chance to catch up for a minute. Okay, the next one that we're going to look at is going to be an interest investment problem. And it's going to be on page 66. Interest on an investment. So we're going to read the problem. Mary inherits $100,000 and invests it in 2 certificates of deposit. One certificate pays 6% and the other one pays 4.5%, simple interest annually. If Mary's total interest is $5,025 per year, how much money is invested at each rate? So this is one we're going to use a chart for. We're going to draw a chart that's going to be 5 across and 4 down. So we have interest on an investment. The first one is going to be the name of what we're talking about. Then interest is principal times rate times time equals interest. So we're going to write those names down. Principal is the amount of money that you're putting into the account. Rate is the percent. Time is annual time. And the amount of interest that you get. Interest is the amount of money that you make from keeping your money in that investment. So it says that she has $100,000 that she's going to invest at 6% and 4.5%. So the two things that she's looking at are a 6% investment and a 4.5%. So she's putting part of her money into 6% and part of her money into 4.5%. And this is going to be the total. So how much total money did she say that she had? It says Mary inherits $100,000 and puts it into 2 investments. So 6% and a 4.5. So the $100,000 is her total amount of money. Now we have to think about this. If she puts part of it at 6%, then the remainder is going to be at 4.5%. The remainder of the $100,000. So do we know how much is going to be in the 6%? No, so we're going to let that be our variable. So we're going to say let x equal the amount of money invested at 6%. So she's taking this 100,000 that this whole amount is in her hands. She's taking and putting part of it at 6%, and the rest is 4.5%. So let's just look at a thing for a second here. If I put $100,000, if I put 20% into 6%, how much left over do I have to put into 4.5? So I'm going to take the $100,000 and take away 20% to put in the 6. That would leave me the remainder of the difference. So difference means to subtract. So I would take $100,000 minus the $20,000. So in this case, using the same idea, I'm putting X into the 6%. I'm using up X of it for 6%, and the remainder's got to be 4.5. So what would the total be this time? 100,000 minus what I used already for the 6%. So this is going to be 100,000 minus X. The difference between what you started with and what you took away. So now we're going to write the rate. The rate we said was going to be the thing with the percent sign on it. So this one we're going to take off the percent sign to be able to use it in the problem. So to take a percent sign off, percent means to divide by 100. So dividing by 100 means moving the decimal place 2 places to the left. So if I have 6% and I want to get rid of the percent sign, then what I do is I start here and go 1, 2 to the left, and that gets the percent sign to go away. So that's like dividing by 100, moving the decimal 2 places to the left. So this is going to be 0.06. 4.5%, we have 4.5%, but half would be 4.5% to start out with, because we start with 4.5, but half is 0.5. So now from the decimal, we're still going to move it to the left 2 places. So I get 0.045. Now I think it's important that you always put that 0 in the front, because that way you'll know that there's supposed to be a decimal there. You don't lose the decimal. So we have 0.045. Our time, they said, was annual. So 1 would be the number of years. The interest is principal times rate times time. So principal times rate times time is going to give me 0.06x. Principal times rate times time on this one is going to be 0.045 times 100,000 minus x. Principal times rate times time as I read across the chart. The last part is no principal times rate times time, but it tells you in the problem that she makes $5,025. So if she makes $5,025, then that would be the interest, the total interest. So total tells us to do what? Tells us to add those two things. So I have 0.06x plus 0.045 100,000 minus x equals 5025. So I'm going to take and distribute. So I have 0.06x plus 0.045 times 100,000 minus x equals 5025. So we're going to take 0.06x plus this times 100,000 is going to give me 4,500. This times x is going to give me 0.045x, 5025. So now we're combining like terms. These two x's are going to go together and give us 0.015x, and this minus 4,500 is going to go to the other side. So we get equals 525. So to finish it off, we're going to divide by 0.015. 0.015. This cancels to be 1. So that gives me x equals 35,000. Now, how do we find out what x stands for? So we're going to go up to our x. X equals the amount of money invested at 6%. So this is dollars. So we have 6%, we have $35,000 invested. But now it says, what does she invest at each one? So if we know 35,000 went to the 6%, going back up to our chart, 100,000 minus X then gives me the other side. So my 4.5% investment is going to be $65,000. So we need to check, do those two things add to be $100,000? Okay, so now let's go to the next one. The next one is on page 69, height of a building using similar triangles. Now, when I think of similar triangles, maybe some of you guys have never seen these before, but we used to have this thing where it was a piece of plastic that you could color and then put in the oven, and it would shrink down. We called them shrinky dinks. So those would shrink down, and they would be similar when they had from one to the other because their sides would be proportional. So this one's on page 69. So we're looking at page 69. The question reads, a man who is 6 feet tall wishes to find the height of a certain 4-story building. He measures its shadow and finds it to be 28 feet long, while his own shadow is 3.5 feet long. How tall is the building? So we're going to draw ourselves a picture. So we have this building. And he wants to know the height of the building. And then he stands over here. So we have these two triangles. So the triangles are going to be proportional. So he says he knows the shadow of the building. So this is the building. This would be the shadow of the building is 28 feet. So over here, he says that he is 6 feet tall. So this is going to be 6 feet. And his shadow is 3.5 feet long. So this is 3.5 feet. And we're trying to find the height of the building. So we've drawn the picture, we've read the problem. So the next thing we want to do is label the variables. So let H equal height in feet of the building. So we're going to set up a proportioner for similar triangles. Now there's different ways you can do this. The first way we can do it is compare the two heights. So H over 6. And then we compare the two shadows. So we did large over small, large over small. So we're going to have 28 over 3.5. Now we do 0.5 because that's the same as 1/2. Another way that you can do it is big one, height to shadow, little one, height to shadow. So height to shadow, height to shadow. Now what we have are two proportions. Proportion is the equality of two ratios. Ratios are like fractions. So we're going to set this up to solve by what we call cross multiply or cross product. Remember, product is the answer to a multiplication problem. So either one of these two answers would be the answer. So we're going to cross product on here. We're going to cross product on here. So this one gives me 3.5H equals 6 times 28. This one gives me 3.5H equals 6 times 28. So you can see that it doesn't matter which one we use. We're still going to get the same equation when we get down here. So we simplify by multiplying and dividing by 3.5. So I get 3.5H equals 168. Divide 3.5 on both sides. So we get H equals 48 feet. and that's the height of the building. Okay, next one we're going to look at is a mixture problem, and it's on page 70. So on page 70, we're doing a mixture problem. It says a manufacturer of soft drinks advertises their orange soda as naturally flavored, although it contains only 5% orange juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. How much pure orange juice must this manufacturer add to 900 gallons of orange soda to conform to the new regulations? So basically what he's saying is that he has this pot of juice that has 900 gallons in it and it's 5%. Okay? So we're going to take this pot, since it's only 5%, we now need it to be 10% juice. So what are we going to have to do? We're going to have to add some more pure juice to that. So now we're going to look at a chart for this problem. The chart is a 4x4 chart for a mixture problem. So again, we have name, base times rate equals percentage. So here's base, rate, percentage. The rate is again the thing with the percent sign. So let's talk about it again. So what are we looking at? We're looking at this jug of juice. And inside the jug of juice, we know that there's 900 gallons of 5% juice. So we also know that we have to add to that 5% to make it 10% juice. So I've got some pure orange juice. So when we're looking at pure orange juice, how much juice is in pure orange juice? Well, that's 100%. Do we know how much orange juice we're going to pour in? Well, if you look at the problem, it says how much orange juice. So that's going to be our unknown. So we're going to let X equal the number of gallons of pure juice that has to be added. So we're going to take this 100% juice, and we have X of it now. We don't know how many gallons. So we're going to look at X gallons. And we're going to add this juice to the other juice to come out with a total of 10% juice. So this over here has to be the 10% juice. So it kind of makes sense. If you have a lower percentage and you're adding a higher percentage, then that percentage of juice is going to raise up. So we have 5% juice, we have 100% juice, we have 10% juice. So this would be the two that you're going to put together to make the 10%. So how much 5% did we say we had? Looking down at our picture, we had 900 gallons. We don't know how much 100%. We said we were going to have a number of gallons of pure juice would be X. So this is going to be X. So if 10% is the total, you said we are adding those two to get this total. 10% is the total. So what are we going to do? We're going to add 900 plus X to get the total amount of juice that you now have. So the rate is the thing, the percent sign, but we want to get the percent sign to go off. So 2 places to the left is going to give me 0.05. 2 places to the left is going to give me 1.00. 2 places to the left is going to give me 0.10. Now see what I did again here. I put that 0 in front of the decimal, 0 in front of the decimal. So base times rate is going to be percentage. So I'm going to have 0.05 times 900. 1, these two zeros doesn't matter, so 1 times x. And 0.10 times x plus 900. So we said these two are going to be added to be the third one. These two are added to be the total. So I'm going to have 0.05 times 900 plus 1x equals 0.10 times x plus 900. So this is the 5%. You're adding the pure juice to get the 10% total. So now we're going to multiply. These two multiplied by each other gives me 45 plus 1x equals 0.10 times x plus 0.10 times 900 going to give me 90. So now it's like one of those linear equations again. We have to solve to get all the x's on one side first. So we're going to take a negative 0.10x and a negative 45. So this cancels to be 0, adds to be 0. This adds to be 0. So 1 minus 0.10 gives me 0.90x. 90 minus 45 gives me 45. Divide by 90, the 0.90. Divides to be 1, and you get x equals 50. Now again, x equals 50 is not your answer yet. You haven't decided what does x stand for. I mean, is x football players running down the field? Is it babies crying? What is it for 50? So we go back. X was the number of gallons of pure juice. So we would have to add 50 gallons of pure juice to raise the percentage up to 10%. Now this kind of problem can be used for a lot of different things. They do it for things like how much raisins and nuts can be put together to make a mixture, how much low-fat hamburger meat and full-fat hamburger meat can you put together. Those kinds of things. You're mixing things together. Okay, the next one we're going to look at is a distance times rate times time problem. So distance problem. All right, this one is on page 72. So the question says, a jet flew from New York to Los Angeles, a distance of 4,200 kilometers. The speed for the return trip was 100 kilometers per hour faster than the outbound speed. If the total trip took 13 hours of flying time, what was the jet's speed from New York to Los Angeles? Okay, so we're going to look at drawing a picture on this one. And we're also going to look at a formula over here. We have D equals R times T. Now you guys have used this before. Distance equals rate times time when you're talking about how fast you'd have to drive to get someplace. So you can also do some manipulations of this and divide by R on both sides. And get time equals distance divided by rate. So you have a lot of different ways that you can rewrite this. You can also rewrite it in terms of rate if you were to want to. So we're going to look at an example. Then now it's going from New York to Los Angeles. So New York, Los Angeles. Now what does it say about between New York and Los Angeles? We know that it's 4,200 kilometers apart. So it says a jet flew from New York to Los Angeles, a distance of 4,200 kilometers. The speed of the return trip was 100 kilometers faster than the outbound. Do we know how fast they were going when they left outbound? No. So we're going to let R be the rate from New York to Los Angeles. So from here going this way is R. Then it says it was faster coming back. So maybe the wind was with them or whatever. But if it's faster coming back, then from Los Angeles going back there is going to be what? It said it was 100 kilometers per hour faster. Faster would imply plus. So this one is going to be R plus 100. So R plus 100 is the rate from LA to New York. So we're looking for the total. It says if the total trip took 13 hours of flying time, what was the jet speed? So we said that we have distance and we have a rate. So to get time, we would have to take distance divided by rate. And we know that the total time, it tells us, is 13 hours. So total tells me I'm going to be adding something. So I'm adding going out to coming back. So how long did it take to go out? How long did it take to go back? So time is distance divided by rate. So this side, the distance divided by rate, is going to give me 4,200 divided by R. Total time means I'm adding them. So plus, on this one, my total distance is 4,200. Distance divided by rate. And my rate is R plus 100. Now, what do these all stand for? These stand for time. Distance divided by rate is time. So what is my total time? My total time is 13 hours. So now I have an equation that's 4,200 over R plus 4,200 over R plus 100 equals 13 over 1. Now we did one like this before where we ended up solving to get this to be a solution set. So our common denominator is going to be R times R plus 100. So we're going to multiply by R times R plus 100 on both sides. As long as we multiply by the same thing on both sides, it's still going to be an equivalent expression. So I multiply this times this, and the R's cancel out, so I get 4,200 times R plus 100. And on this one, this times this, the R plus 100 cancels out, so I get 4,200 times R. And over on this one over here, we're just going to get 13R times R plus 100. So now we use distributive property, 4,200R plus 4,200 times 100. You're doing distributive property. So this is going to give me 42,000 plus 4,200R. This 13R now is multiplied into both of those. So we get 13R squared plus 1,300R. Now, because we have a squared term, that makes this a what kind of equation? Makes it a quadratic equation. So we want to move everything over to the side where the quadratic is positive. So I'm going to add the 4,200R and the 4,200R. So I'm going to subtract 8,400R from both sides. And my 42,000, 420,000 is going to subtract over 2. So these cancel out. 13R squared minus 8,400 minus 1,300 would give me 7,100R minus 420,000 equals 0. So we're going to give everybody a chance to get caught up to that case. So we left off with 0 equals 13R squared minus 7,100R minus 420,000. So what we're going to do then is we could either try factoring to see if factoring will work, but we're going to just go right into the quadratic formula. So we're going to have R equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Because r is our variable this time, there's no x there. So I have r equals negative 7,100. That would be our negative b plus and minus the square root of b squared, so negative 7,100 squared. 4 times 13 times a negative 420,000 all over 2 times a, so 2 times 13. So now a negative times negative gives me a 7,100 plus and minus the square root of. So I'm going to square this. Notice this is negative times negative, which makes this quantity over here be positive. So whatever this is squared plus this is going to give me 7,225,0,0,0 all over 26. So when you work this out, you're going to get this plus this divided by 26, this minus this divided by 26. So you get 600 and you get some negative number. You could work it out if you want to, but you know it's going to be a negative number. So what does the 600 stand for? So if I go back to my original problem where I was drawing the picture, we said R stood for the rate from New York to Los Angeles. So our rate from New York to Los Angeles is 600 kilometers per hour. Now, again, going back to our previous page, R plus 100 is the rate from LA to New York. So if we wanted that one, then R plus 100 would be 600 plus 100 would be 700. So Los Angeles back to New York, they were going 700 kilometers per hour. So always check your answer to see if you answered the question. So it says, what was the jet's speed from New York to Los Angeles? So what was the speed from New York to Los Angeles is your 600 kilometers per hour. Give her a big chance to catch up to that one. Okay, the next one we're going to look at is what we call consecutive integers. Now, consecutive means one right after the other. So we're going to look at two things. We know the integers are the set of numbers -3, -2, -1, 0, 1, 2, 3, and so forth. So it's the whole numbers plus their opposites. So give everybody a chance to catch up to that point first. So if the integers, consecutive integers, are one after the other, we're going to let n be the first one. And then the next one is going to be n plus 1, because the next one to get from 0 to 1 would be added 1, 1 to 2, added 1. This would be the second integer, and so forth. So now I'm going to give you guys a minute or two to write down the next 3 integers and see what they would be. All right, so each one adds 1 each time. So n plus 2, n plus 3, n plus 4, and so forth. So this would be what we call consecutive integers. Now, we not only have consecutive integers, but we also have consecutive even or odd integers. So we've got consecutive even or odd integers. So what would if I start out with n being my first even integer? So say this was a 2. My next even integer would be a 4, 6, 8, and so forth. So how do I get from 2 to 4, 4 to 6, and 6 to 8? I add 2. So I get n plus 2 equals the second even integer. Now, it might also be good to put consecutive even integers. So now you have consecutive even integers. The next one would be n plus 4, n plus 6, and so forth. But what about odd? And this is where we get confused sometimes. If I let n be the first odd integer, then say 3, 5, 7, 9, 11, and so forth. How do I get from 3 to 5? From 5 to 7, 7 to 9, I add 2 still. So we have the same thing, n plus 2, n plus 4, n plus 6. So the question is going to say, find the sum of 3 consecutive even integers. Find the integers if the sum is 132. So sum means that we're going to add some things. So the sum of the 3 consecutive even integers is 132. Well, the first one is going to be n. First even integer. But I said I want 3 consecutive even integers to be 132. So this is going to be n plus 2 plus n plus 4. These would be the first 3 even n plus 2, n plus 4 consecutive even integers. And that was going to be 132. So I add all the n's together, and I add the 2 and the 4 together, and I get 3n plus 6 equals 132. So minus 6. 3n equals 126. Divide 3, and I get the first one to be 42. But they're consecutive even integers. So if the first one's 42, then I know the next one's going to be 44, and the next one's going to be 46. So I've got my 3 consecutive even integers that add to be 132. I'm going to do one more with consecutive integers. So this one's going to say the sum of the squares of two consecutive integers is 481. Find the integers. So if we have to know some names of things, sum of squares. Sum means I'm going to be adding. Squares that I'm going to do is squaring it of two consecutive even, not consecutive even integers, but two consecutive integers is 481. So the first integer is going to be n. Now, they're not even or odd, they're just consecutive. So what do I have to add? N plus 1 is the second one. But what am I doing with these two integers? I'm adding them, the squares, to be 481. So n squared plus n plus 1 squared equals 481. So I got n squared plus n plus 1 times n plus 1. So now I've got to do FOIL on this. So I get n squared plus n squared, 1n, and 1n is going to give me plus 2n plus 1 equals 481. So now I combine terms. So 1n squared and 1n squared gives me 2n squared plus 2n. I'm going to bring the 481 over. Positive 1 and a negative 481, subtract and take the sign of the larger, so I get 480 equals 0. Now you can see that there's a 2 in common all the way across. So we're going to distribute out a 2. N squared plus n minus 240 equals 0. To get rid of the 2 now, since it's multiplied, I can divide by 2 on both sides. So that cancels to be 1. This cancels to be 0. So now I have a quadratic trinomial, so we're going to factor. I get n and n. I'm going to help you out. 15 and 16 multiplies to be 240. Since we have to have a positive 1, we know the 16 has to be plus, minus. So I get n minus 15, this is still equal to 0, equals 0. N plus 16 equals 0. Now, what did we call this from before? We called it the zero product rule, which says that if two things multiply to be 0, then one of these two things has to be 0. So plus 15 minus 16 gives me n equals 15 and n equals negative 16. Now, this is the n. This is the first integer. So what would the second integer be for 15? 15 plus 1 would give me 16. So my two integers are 15 and 16. This one, if I add 1 to it, 1 plus a negative 16 is going to give me negative 15. So then this is my... Now, why does it not matter? Because this one's got a negative and this one doesn't have a negative. Well, when we look back at our original equation, we were squaring it. So if you're squaring it, the negative is going to go to become positive anyway. So we've got two sets of answers on this one, 15 and 16, and negative 16 and negative 15. There are lots more examples that are in section 1.7, starting on page 65, if you want to go back and do some more. So thank you very much.